Because we're dealing with friction on a horizontal surface with the force applied parallel to the surface, we can make the following two assumptions. Assumption 1. The only downward vertical force between the object we want to slide and the surface it sits on is the object's weight. The weight of the object will be directed vertically downwards, so it is perpendicular to the plane. Therefore, the object's weight will be the only force pushing the surfaces of the object and the plane together. Since Rn, the normal reaction force, equals the force pushing the surfaces together, Rn will equal the object's weight. Assumption 2. Because we will be applying the force parallel to the horizontal plane, all the force will be directed towards sliding the object and overcoming friction. Using the above two assumptions gives us three possible scenarios to deal with. Case 1. If we apply a force to an object at rest and it doesn't move, then the friction force equals the applied force. Don't forget, friction force is a reaction force and will match the applied force to a maximum value. Example 1. An object having a mass of 75 kilograms sits on a horizontal surface. The coefficient of static friction between the surfaces is 0.35. If a force of 100 newtons is applied to the object, what is the friction force? Example 1. An object having a mass of 75 kilograms sits on a horizontal surface. The coefficient of static friction between the surfaces is 0.35. If a force of 100 newtons is applied to the object, what is the friction force? Since they don't tell us the angle the force is applied at, we are going to assume it's horizontal to the surface. Observation. Since we don't know if the applied force is enough to start the object moving, we will find the maximum static friction force. Step 1. Finding the object's weight. Weight equals mass times g. Weight equals 75 kilograms times 9.81 meters per second squared. The weight of the object is 735.75 newtons. Step 2. Finding the normal reaction force, Rn. Since the only vertical force down is the object's weight, the weight is the force pushing the surfaces together. Therefore, Rn equals W, or the weight. So the normal reaction force will be 735.75 newtons. Step 3. Finding the maximum static friction force. Maximum static friction force equals the coefficient of static friction times the normal reaction force Rn. The maximum static friction force equals 0.35 times 735.75 newtons. The maximum static friction force is 257.5 newtons. So that's the maximum static friction the reaction force can offer to the applied force. Step 4. Finding the actual friction force. Since our applied force is less than the maximum static friction force, then the friction force equals the applied force. So the static friction force will equal the applied force. The static friction force will equal 100 newtons. not 257.5 newtons. Case 2. If we apply enough force so the object just starts to slide, then the applied force equals the maximum static friction force. We can find the maximum static friction force using the formula. Maximum static friction force equals the static coefficient of friction times the normal reaction force. Example 2. A 50 kilogram mass sits on a floor. What force is required to just start the object moving if the static coefficient of friction is 0.5? Example 2. A 50 kilogram mass sits on a floor. What force is required to just start the object moving if the static coefficient of friction is 0.5? Step 1. Changing the mass to weight. Weight equals mass times g. Weight equals 50 kilograms times 9.81 meters per second squared. The weight of the object is 490.5 newtons. Observation. Since the only vertical force down is the object's weight, the weight is the force pushing the surfaces together, so the normal reaction force Rn equals the weight. Rn therefore equals 490.5 newtons. Observation. Since we are applying just enough force to start the object moving, then the maximum static friction force equals the applied force. So step 2 will be find the maximum static friction force. Maximum static friction force equals the coefficient of static friction times the normal reaction force Rn. Maximum static friction force equals 0.5 times 490.5 newtons. The maximum static friction force equals 245.25 newtons. Step 3. Finding the required applied force. Because the object is just starting to move, we know the applied force has to equal the maximum static friction force. Therefore, the applied force has to equal 245.25 newtons. Case 3. If we apply just enough force to keep the object sliding at constant velocity, once it starts to slide, then the applied force equals the maximum kinetic friction force. We can find the maximum kinetic friction force using the formula. Maximum kinetic friction force equals the kinetic coefficient of friction times the normal reaction force. Example 3. A crate has a weight of 800 newtons and requires a parallel force of 300 newtons to slide it at constant velocity along a horizontal surface. What is the coefficient of kinetic friction? Example 3. A crate has a weight of 800 newtons and requires a parallel force of 300 newtons to slide it at constant velocity across a horizontal surface. What is the coefficient of kinetic friction? Step 1. Finding Rn. Since the only vertical force down is the object's weight and the weight is the force pushing the surfaces together, then Rn equals the weight. So if the weight is 800 newtons, then Rn, the normal reaction force, is also 800 newtons. Step 2. Finding the maximum kinetic friction force. Since the object is sliding at constant velocity, then the maximum kinetic friction force equals the applied force. So the applied force is 300 newtons, so the maximum kinetic friction force is 300 newtons. Step 3. Finding the kinetic coefficient of friction. So we know from our formula, maximum kinetic friction force equals the coefficient of kinetic friction times the normal reaction force. We can rearrange that formula so that the kinetic coefficient of friction equals the maximum kinetic friction force divided by Rn, the normal reaction force. So UK will equal 300 newtons divided by 800 newtons. UK, the kinetic friction coefficient of friction, will equal 0.375. Deciding which of the above three cases we are dealing with and using one or both of the following two equations, we can solve all friction problems on a horizontal plane with a force applied parallel to the plane. Example 4. A 90-kilogram woman stands on a horizontal surface. What must the static coefficient of friction be between the soles of her boots and the surface in order for her to start to slide a 250-kilogram mass across the surface without slipping? Take the coefficient of static friction between the object and the surface as 0.3. A 90-kilogram woman stands on a horizontal surface. What must the static coefficient of friction be between the soles of her boots and the surface in order for her to start to slide a 250-kilogram mass across the surface without slipping? Take the coefficient of static friction between the object and the surface as 0.3. Observation. In order to start to slide the object, the woman must apply a force equal to the maximum static friction force generated between the object and the surface. Step 1. Finding the weight of the object. Weight equals mass times g. Weight is 250 kilograms times 9.81 meters per second squared. The weight of the object is 2,452.5 newtons. Step 2. Finding Rn for the object and the surface. Since the only vertical force down is the object's weight, the weight is the force pushing the surfaces together, so Rn, the normal reaction force, equals the weight W, so Rn equals 2,452.5 newtons. Step 3. Finding the maximum static friction force between the object and the surface. Maximum static friction force equals the coefficient of static friction times the normal reaction force. Maximum static friction force equals 0.3 times 2,452.5 newtons. The maximum static friction force between the object and the surface is 735.5 newtons. Step 4. Finding the force required to start to slide the object. The force required to start to slide the object will equal the maximum static friction force. Therefore, the applied force has to be 735.5 newtons. Observation. In order for the woman to apply 735.5 newtons of force to the object without sliding, the maximum static friction force between her soles and the surface must also be 735.5 newtons. Maximum static friction force for the woman is 735.5 newtons. So, in order to overcome the maximum static friction force of the object and the surface, she has to apply the same amount of force, which also has to be the maximum static friction force between the soles of her shoes and the surface to keep her from slipping. Step 5, finding the woman's weight. Weight equals mass times G. Weight equals 90 kilograms times 9.81 meters per second squared. The woman's weight is 882.9 newtons. Step 6, finding the value of Rn between the woman and the surface. Since the only vertical force down is the woman's weight, the weight is the force pushing the surfaces together, so Rn equals W. So the normal reaction force for the woman is 882.9 newtons. Step 7. Finding the required coefficient of static friction between the woman's soles and the surface. The static coefficient of friction equals the maximum static friction force divided by the normal reaction force. The coefficient of static friction will therefore equal 735.5 newtons divided by 882.9 newtons. So, the static coefficient of friction has to be at least 0.83 between the soles of the woman's boots and the surface in order for her to apply enough force to start to slide the object without her herself slipping.